I thank Dr. Suruprakash sir for inviting me today for this CTO session. I think it's not so easy to captivate viewers on the day of Chandrayaan 3. I think, yeah, I'll try my level best to captivate all of you. Anyway, Antegrade CTO PCI made easy. See, over a period, the success rate of CTO PCI has been increasing, and more importantly, Antegrade PCI success has been growing, and with the addition of Antegrade dissection and re-entry techniques. See, the most important in Antegrade success is the cap. So the cap, the clarity on the cap, and the clarity on the distal vessel. These are the two primary factors, which it decides the success of Antegrade PCI. And if you look at all algorithms, what comes first is the cap ambiguity. So that is where your CTO PCI wiring strategy starts. Let me dwell a little bit deep into this Antegrade prerequisites. See, only when you know where the cap is, so you can really start wiring. So if you know this is a cap, you know where you have to enter into the CTO. Then if your distal vessel is visible clearly, then you know where you have to reach distally. See, and that is the key in Antegrade success. If you don't have a clear cap, and if you don't have a clearly visible distal vessel, then you are going to struggle with Antegrade, CTO PCI. I mean, those are the patients where obviously you need even a retrograde to work on. So what happens when there is a calcium, within the CTO? So calcium is the it spoils, your antegrade or retrograde, any PCI. So if the calcium is sitting, bunch of calcium is sitting in the CTO, what exactly happens is it deviates your wire. It deviates your wire to subintimal space or, extra block space. So that's when, the chances of ending up in a extra block area, that is a subintimal area, increases. And even in a short CTO, calcium sitting in a CTO body will spoil your antegrade wiring. So you need to have re-entry methods, in such cases. So, and when there are angulations, okay, how angulations affect your antegrade PCI or even in long lesions? Let's say, this is how you see the vessel and how you connect these two ends. It can be like this, or it can be in a different way as well. So it can be like this, if it is a tortuous coronary, right coronary, it can be like this. I'm just putting down one article on RC anatomy and CTO interventionist perspective. Probably you can go through it. So which shows a lot of tortuous anomalies in right coronary artery. So always right coronary artery has a C-shaped artery, but it may not be C-shaped. There can be a lot of tortuosities in the proximal segment, mid segment, as well as the distal segment, which will become spoil sport for your antegrade wiring. So, and whenever you are steering wire in an angulation more than 45 degrees like this, and that is when, again, your wire may end up in a subintimal space and also in long lesions. So these are the things, which minimizes, your success of antegrade interventions. So, and if you look at a cap, see, this is, you can see here, there is a clear cap, and you can also see here in a dual injection, there is a clear distal target. So when you have a clear cap and clear distal target, that is when, you can steer your wire antegradely. So, and you can enter where you want to enter, and you can reach where you want to reach with directable wire. Let's see here. So what happened here? See, you don't know where you have to perforate. Okay. Yeah. So you don't know where you have to perforate. It's a kind of ambiguous cap. Let me just change to arrow. So, okay. So you don't know where you have to perforate. It's all ambiguous. Okay. And so that is when you can see here whether I have to perforate here, here, or here. You don't know where from the continuity of LED exists. So that is when it's very difficult to escalate wires to high tip load wires, because when you're escalating wire to high tip load, directable, you should know the direction, where you want to direct it. So you can't just go blindly into such CTOs. Yeah, so you can see here, so this is again a RCS CTO, and you can see there is some distal vessel visible, but what is more important is this degree of clarity, whether it is enough to understand your wire and distal vessel relation. That is the most important thing, unless you understand your wire distal vessel relation, you can't really proceed in an antegrade PCI. So again, it boils down to visibility. See, my wire has gone up to this, but from here, it is very difficult to decipher. You can see the distal vessel. It's not so clear, to really define, where it is. And usually you end up in a failure. So you need to go with an alternate strategy, to do such cases. So coming to the micro channels in an antegrade PCI. So this is something which is very important, and which you can make out, when you see multiple times your case. And wherever it is still meaningful to try with a microchannel wire before you upgrade to stiffer wires. You can see here. So to visualize microchannel, so if it is not visible, right, you can take a microcatheter injection. You see here, and you can clearly see a microchannel here. So microcatheter injection will make you understand, the microchannel pretty well. And you can, the most important thing here is you have to observe your distal cap, okay, where the distal vessel is filling first. If the distal vessel is filling first at the distal cap, that means there is high likely that there is some microchannel. Then you have to start tracing it upward. So if the distal cap area is filling from below upwards, that means there is no microchannel. So it's basically some filling from collateral. So the detailing of the contract you have to pay attention to understand whether there is a microchannel or not. So once you make out a microchannel, because it is quite easier to close the case with the microchannel wire. So the best wire for microchannel tracking is what I use, and what most of the operators across comfortable with is Fielder XTR. So Fielder XTR with the advantages is the tip is 0.09. That's a taper tip wire, and tip load is actually less than 0.8 grams, around 0.8 grams. So it's a taper tip, low tip load wire. So, and which is high likely to, and also it's a slippery wire because of polymer coating. So these are the qualities of microchannel tracking wire. So you can use a Fielder XTR, and if at all, if you need some more tip load, you can even use a Fielder XTA, whose tip load is around 1.2 grams. So I think these are the wires which I use. Fighter is also good wire to use, but honestly, I stopped using it because of its tip load, because its tip load is almost like 1.5 grams, which is something equivalent to your Gaia 1. So the chances of going subintimal are slightly high with fighter wire when compared to fielder XTR. So this is, yeah, so these are the qualities, which you need. But of course, there is a trade-off. So a low tip load, small small tip size, and slippery wire never gives you a great steerability, right? And great tactile feedback. So there is a trade-off. So you don't see any tactile feedback with this wire. So the most important is never push this wire, only rotate it. It will choose the path, which is available in the CTO. So this is not a wire to direct. If you try to direct, you end up in creating a micro dissections and probably even a subintimal entry. So as I already mentioned, so you can see here, so we saw with the microcatheter injection, you can clearly see there is a micro channel. And now you can see this is a fielder XTR wire. So you just rotate wire. So practically here, we are not really directing wire. Just keep rotating it, it will take the channel available and it will go down. And you can see it just went down, right? And usually it will be in true lumen. So you can also see this case where actually almost the channel is not practically visible. So not practically visible, but still my first choice was, microchannel wire. So I used a microchannel wire. This is a fielder XTR, you can see, and that fielder XTR actually reached a distal true lumen. Though it is a long CTO, so we could reach distal true lumen much easily, with this wire. So it is worthwhile using microchannel wire before escalating to your next wires. And my usual escalation strategy is, honestly, if I want to try a microchannel, I'll do a exploration with fielder XTR. If it doesn't work, then I'll move on to Gaia 2. So in last 3 years, I would say I have not used Gaia 1, not even once. So I escalate to Gaia 2, and then if Gaia 2 is stuck and non-progressive, then I escalate to Gaia 3 or Hornet 1014 or Conquest 12. So, and usually I de-escalate wire immediately back to again Gaia 2. So this is my escalation, de-escalation strategies. But this works when you clearly know the course of the CTO. If you don't have an idea on CTO course, then the better wire to escalate is polymer jacketed wires, that is pilot. Because chances of, to direct Gaia, you need to know the vessel course, that is a CTO course, because you have to direct and push these wires. If you don't know the course, better use pilot, because pilot generally don't perforate, and go out of the vessel architecture. But these Gaia 2, Gaia 3 can easily go out of the vessel architecture. So the bottom line to escalate into this sequence is knowing the track of CTO, right? So yeah, and why you have to de-escalate? See, whenever your Gaia 2 is stuck somewhere, you just take a Conquest or Hornet 1014 and take that wire across the point where your Gaia 2 is stuck. Just make a hole there and come back with the wire, because those are stiff wires. They don't listen to you. They just go straight, right? Even if there is a small angulation, it is high likely that these wires will end up in a subintimal plane or even extra vascular plane. So you just where your Gaia 2 is stuck, make a hole, pull out that wire, and again go back with Gaia and continue your subsequent exploration of CTO. That's a principle which we have to use in escalation, de-escalation strategy. I think you can see that, this is a clear vessel and clear distal vessel. And you can see here, so I tried with the fielder XTR, but it didn't go. and then we escalated to Gaia 2. And since we know the distal vessel codes, so we directed Gaia 2 into the distal vessel. And now comes understanding your escalated wire relation with the distal vessel. That is very, very important, which many neglect during the course of intervention. So what is important here is, so once you reached the distal cap, from then every 1 millimeter, I think you have to make sure where your wire is, okay? And you have to make sure where your wire is in 2 orthogonal views. It's not in one view. So to understand wire and distal vessel relation, so you need 2 orthogonal views. Only when wire is in the lumen in 2 90 degrees views, here I used a caudal and cranial, but ideal for this LED location is areocranial and aleocranial. That is easiest view to handle the case. So not caudal cranial, but often I use caudal cranial as well, but the best is aleocranial. So in 2 orthogonal views, if the wire is in the distal vessel, that says yes, your wire is in distal vessel. And then to confirm further, you can just give a slide on the wire. You just push the wire, give a quick push on the wire. If the wire is moving without buckling, that says you are in a true lumen, right? But that quick push, shouldn't be too hard push, because if you are in a subintimal plane, that push is enough to create a huge space, and your next efforts becomes futile. So, so once you confirmed, where the wire is, then, you can, from there onwards, it's only a simple, Antegrade PCI, right? So sometimes, like in this case, you can see it's an ambiguous cap, and you see, where, you can identify with IVUS, we are doing IVUS from diagonal, and this is a cap. So how to identify cap? So there are 2 simple markers in IVUS. One is jump in the size of the vessel, right? Another is disappearance of media. So again, I'll just show you this from here. You can see here, you can see the media all around, or the vessel all around. You see here, there is some shadow is appearing here, and now your media is disappeared there, okay? You see the point where the media is disappeared. That is where, your vessel is. Now next, keep observing this. The vessel jumps. You see this jump in vessel size. So these are the 2 signs, which you shouldn't miss, and which makes you understand, where your proximal cap is. So once you make out, you can also study the nature of the proximal cap. You can see here, can you see here, this is a proximal cap. You can see there is a bright spot here, right? So I think it's a kind of fibrotic, or maybe it could be some calcium speck. I don't know. I never gave any importance to it when I was doing this case, but you see what happened subsequently in this case. So you can see this is, I'm using a slipstream method to do a live IVUS guided cap puncture. There is a wire, and on which, there is a IVUS, and as well as there is a double lumen catheter, and through double lumen catheter, I'm sending this Gaia 2. So both IVUS and double lumen catheter are on the same wire. Okay, and if you see the, just observe the wire tip. It is just buckling. Sorry, it is buckling. Can you see the buckle? The bend in the wire. So it is just buckling. Why it is buckling? It is simple. This is a speck, right? Which this wire cannot perforate. So no point in trying with the same wire again and again. So what you have to do is, and if you see this speck, that's a very focal speck. So just escalate your wire. You can see here now, this is how, your Gaia behaved. You can see the Gaia is buckling, right? And now you can see this is a harnett wire. Okay, this is a harnett wire. Harnett wire goes just straight. It won't buckle, right? So you just go straight and rotate it, right? And you can make a hole in it and then pull it back. So don't continue with the same wire, because that wire is only to perforate the point where you're not able to cross. It's not the wire to cross entire CTO. So idea here is your guy is not going in because of that spot. You address the spot, come out and go back with your Gaia. So, and hardnet we perf. Oh, you want to, which where you want to go back? I perforated only proximal cap here, not entire CTO. Okay. It's only the cap I perforated. Yeah. Okay. Anyway, so it needs, high tip load wire. See here, I perforated proximal cap and then de-escalated back to Gaia 2 to cross rest of the CTO. We have not completely crossed CTO here. Okay. So anyway, and next you can see the last picture. Oh, sorry. I think you can see this is a last, again, the Gaia 2, right? You can observe, how it goes now. Once I perforate it, there is no buckling, right? So that is what happens. So create a hole and go back to your Gaia 2, that is a CTO. So escalation and de-escalation is the most important thing, and it has to be done stepwise. When you are stuck in a CTO, and never continue with the escalated wires like Conquest or Hardnet. Never try to cross with the same wire, rest of the CTO. Anyway, so yeah, my Gaia is gone further here. You can see it is going further, and then reached Distal vessel, and yeah, later we can do rest of the things. So. Yeah, I think this is a clear demonstration. See, if the wire goes, subintimal here, you can see. So when your antegrade wire entered in the distal subintima, so what you have to do is you can redirect same wire with a 3D wiring. So you have to understand where the wire is in the vessel lumen and then do a 3D wiring. That is a bit difficult, and it's not totally predictable. Because there are so many, more than 60 types of positions, which wire can have. And I think it is beyond human intelligence to really interpret it. And next is, you can use a parallel wiring, right? And you can also use re-entry with a stingray. So when it is subintimal, and you can as well use, tip detection ADR in such cases. And you can see this is, in this case, yeah, my wire entered in a subintimal plane. What is most important is you have to understand where your wire is. See, this is all 3D wiring. I don't want to dwell too much and how I rotated all that stuff. I think this is something which you have to close your eyes and understand, where the wire is and rotate. So the two things which are important here is where do your tip is, where the body of the wire is. These are the two things which plays a crucial role in 3D wiring. So let me just, this is something which I did with the 3D wiring. So wire was subintimal. So, and we located it and we twisted the, anti-clock and, pushed down. And then we entered in a true lumen and, and we closed it. So this is another case, same. So essentially 3D wiring is one possibility which can be used in when antegrade escalated wire ends up in a subintimal plane. But see, let me also tell you, see, it's beyond, at least it is beyond my intelligence. I'm successful in, I would say, only 40 to 50% of cases, not all cases. So it's beyond human intelligence to really master this technique. So, but with the advent of tip detection methods, I think that becomes more and more predictable now, and that comes under human intelligence or human maneuvering. So IVUS guided 3D wiring is much easier and much more predictable than simple fluoro guided 3D wiring. So I'll just leave it. Yeah. So in a case like this where, Nasra sir, you have to tell me when I have to stop, okay? Yeah. So in a case like this where you can see here, it's an oscill LED, total occlusion, and yeah. So we tried antegrade wiring. So you can see the wire is in subintima. You can clearly see the wire is in subintima. So what to do now? So the most important thing now is first you confirm where your entry is. If your entry is intimal, right, at the ostem of the LED, so it's a good case to do a re-entry, right? If your entry is not correct, then never do re-entry. Because if your entry is not correct, then you're going to close even LCX. So that's fundamentally important. That is the reason oscill LED CTO, IVUS guided cap puncture is very important, because when you do that, so you will have multiple options available later on. So otherwise your options will be limited. So what we did here, we just took a Stingray and we tried a re-entry. So you can see here, but we create a lot of subintimal hematoma. Then we did a section, and I moved Stingray to a location where subintimal hematoma is slightly less and lumen is better visible. And again, we tried re-entry. You can see here, initially I tried re-entry here where there was huge subintimal hematoma and true lumen is completely compressed. I went back and again retried. So, and now you can see it just went. So it's we stick with the Stingray wire and then swapped with the pilot wire. So you can see how it is going. So that's one thing, which can be done. Yeah. So in such cases, so avoid subintimal hematoma and come to a zone where there is less subintimal hematoma and try and re-entry. So these are some tricks, to make your re-entry more successful. And yeah, coming to IVUS guided entry, when you are using IVUS guided entry, the best way is use 7 French guide or 8 French guide. So in 7 French, you can go with optic cross IVUS and fine cross microcatheter. But if you want to use Corsair, you have to use 8 French. And if you want to use the Crusade, again, you need a 8 French. That is slipstream technique. So you can see here. So this is again an ambiguous cap. So you don't know where the cap is. So whether the cap is here, here, and so what we did IVUS and then located the cap. And once we locate cap, I already told you 2 principles which makes you identify the vessel. So you see this is where the vessel is, right? And where the media is disappearing, you keep observing in entire circle. So media disappeared here, that is the location, and the jump in vessel size. You can as well see the wire. So we already wired it. So in all in the media, so that is the principle on which your cap puncture works. So in every view, the wire should be within the media. So once you confirm that, then you can proceed subsequently. But in this case, what happened is we confirmed the wire entry. You can see it is within the block and within the media all around in all slices, but still again it entered subintima later on. So that's what happens. Any bend and calcium in CTO. So you can see there is a bend here. So that bend actually caused wire deflection, and wire ended up, we entered perfectly, but the wire still ended up in subintima, though the CTO is too short. So that's what happens. And when that happens, yeah, so you have to look at your next technique. So either go retrograde, or you can even do a re-entry. So I think in that case, I went retrograde, but I was stuck even retrograde, so I had to do a Stingray re-entry. This is another case of ambiguous cap. You can even see CT to identify or locate the cap, and which you can extrapolate onto your fluoroscope, you can see this is a cap actually. So exactly you can pull your CT picture back onto, that's a CT fusion into lab, and you can do it, or you can even use IVUS and just to locate and subsequently, puncture. So anyway, here also we punctured, but I think subsequently the wire went subintimal later on, so I had to use a retrograde wire and then marker wire technique and complete the case. So that's fine. So you can see here, yeah. So this is what happened. So we punctured antegrade with IVUS, but still the wire entered subintimally. Then I went retrograde, and this is a retrograde wire. We used retrograde wire as marker and then directed antegrade wire into the distal true lumen and completed. So even after IVUS guided cap puncture, we shouldn't assume that case is over. So cap puncture is only one step, and reaching distal true lumen is another step. So if you don't reach distal true lumen, you can again use a marker wire, putting a retrograde wire, or you can even use re-entry. If your entry is proper, you can use a Stingray re-entry. So this is slipstream technique in which, we basically keep IVUS as well as W-lumen catheter on the same wire. So this is possible with a short monorail IVUS like OptiCross. So wherein the IVUS catheter is short monorail, so your IVUS is here, so and your rest of the wire is free. You can keep a W-lumen catheter on it, and you pull the transducer to the entry, and that gives you a live visibility of your proximal cap, and then you can puncture. But what makes it more complex is after puncture, removal. That is the most important thing, because you have a crusade and you have a IVUS there, and you punctured proximal cap, and you are just 3 to 4 millimeters into the CTO. What is important is, this is like this. Now you have to save this wire position and remove your stuff out to send a microcatheter in, right? So that is when it becomes more interesting. So what you have to do here is, you can see, I think in this case, so what I did, you see this IVUS catheter is still there. I pulled wire back. Okay, first we pulled wire back. Once the wire is pulled back, but not into the crusade, right? Your IVUS catheter is out of the wire, right? So now you can put IVUS catheter is now out of the wire. I am pulling out IVUS catheter out of system. So once IVUS is out, there is a space. You can send a trapper balloon. You trap your wire, antegrade wire, and remove crusade catheter, and then send your microcatheter. So this is very, very important step. Otherwise, you will lose that 3-4 millimeters of position which you have got in the proximal cap, and again you will start reworking on it for next half an hour. So consolidating your position is very, very important when you use a slipstream method of entry into proximal cap. Otherwise, you might lose. So you can see here. So we entered, and then the wire went down, and then we completed case, since it is a short CTO. So coming to the dissection re-entry, yeah, this is my personal data, wherein actually ABR contributed significantly to my success. It is 12% of my cases success. And there are various ADR strategies, but I think these are the most predictable ADR strategies. Even last we are not using, we use in few cases, but mostly it is the Stingray re-entry. Because that causes less anatomical distortion and less intramural hematoma and high success of distal re-entry. It can be used as a first strategy or after failed initial strategy. When you want to use it as a first strategy, what is most important is there should be a clear cap, all right, and then clear distal vessel. So otherwise you can't use it. You can see here, this is one case of both CTO of RCLD, and we tried antegrade wiring. You can see we tried antegrade wiring, but I couldn't it was not successful because of part of the thing is because of the visibility. Then we switched to ADR. So when you're planning ADR, what is important? The first step is, where you want to re-enter. So you have to fix your re-entry vessels. Okay, here this is PD and this is where I want to re-enter because there is a large PD. I don't want to lose that. And second, once that is done, then you have to fix your support. You need a good support to do ADR. So you have to fix your and then fix support. Yeah, okay. So fix your support, then move on. So what happened here? So I went with the cross boss. You can see this is a cross boss, and I'm advancing cross boss further. And this is where cross boss is stuck. So that's what happens when there is a calcium. So, and when cross boss is stuck, what you can use is you can use a knuckle wire. So you can see this is a knuckle wire. Again, use knuckle wire only to cross that point, not the entire CTO. So we crossed that point with knuckle wire. And then again, I advanced, cross boss. And then you can see we advanced cross boss now to the distal landing zone. So you have to advance cross boss up to the distal landing zone. You can see here. So it is in the distal landing zone now, where I wanted to re-enter. Then use a miracle wire, which supports you better. Miracle wire gives a good support for pushability of Stingray. So that's why, that is recommended. Don't do it on Gaia or any other wire because they won't support, Stingray pushability. So once your Stingray is there, what is more important now is you have to understand the lumen to Stingray balloon relation. So that is to understand the luminal entry. So you need to see abluminal entry, luminal entry. It's only based on the retrograde injection. So for that you have to see a vessel. So in this case, actually it was above. Its visibility was poor. But what I did is the initial angio pictures with which I understood, the location, and then we just punctured. So what we did here, we just punctured. The general rule is, your crossbars goes through the outer wall of right coronary artery. So always your entry will be inside in a right coronary artery, but it need not be the same in every vessel. But often it goes like that. Okay. So what you can do when you don't know where the lumen is, you always puncture into inner side and you can close it. So what we did, we just punctured with the Stingray wire, and then you can see this is swapped to pilot wire. So stick with Stingray wire, swap to pilot wire. Stick and swap is my default strategy. And you can also do stick and drive. That means the wire with which you punctured also you can drive across. But that is possible only when the vessel is good and there is no distal disease. If there is a distal disease and the vessel is small, that is not a good strategy to do it. So it's always do a stick and swap. So your chances of ending up in true lumen will be much higher. So you can see this is a kind of strategy, which you have to have in your mind while doing such cases. So you have to have entire map of your, and then I think you can see this is a final result in this case, which is quite good, and PDA, PL, everything is flowing. This is another case we can show, or we can stop here. They're ready? Okay. So I think this is also again same re-entry. So to conclude, Antegrade can be an initial strategy, except in iodo-osteal CTOs, where you have only one route. Unambiguous cap and clear distal vessel are prerequisites for Antegrade wire navigation. Ambiguous cap made unambiguous with intravascular ultrasound, And wire escalation pattern is operator dependent, but largely this is my escalation and de-escalation strategy, which have been using since last more than 5 years without much deviation. And de-escalation is preferred to avoid subintimal entry. And antegrade wire escalation ended in subintimal position. I think these are the things which you can use. You can use a 3D wiring, parallel wiring, Stingray re-entry. And successful re-entry needs good visibility of lumen relation with which depends on balloon preparation. And ADR increases success rate of CTO PCI by more than 10%. I mean, that is out of my experience, it contributes 12% to my success. ADR with Stingray is predominant option as re-entry is more predictable than other wire-based strategies. Before switching to ADR, check guide support and plan dissection strategy well, and preserve your re-entry zone always. Knuckle wire helps in ambiguous course, and also in ADR, intramural hematoma needs some attention and prevention. Thank you. I think we can.
What should be the next strategy? Wire, parallel wire technique, or we have to go for 3D wiring?
No, see, 3D wiring is not really, I mean, I told you already, even I haven't mastered that. And it is very difficult because whatever the concept showed, that shows nearly more than 60 kind of wire positions in a 3mm vessel. And it's practically impossible for human mind to navigate through those 60 positions and, to decide on which rotation, how much, anti-clock, clock, 45, 90 degrees. I mean, it's practically impossible. And second thing, that entire philosophy of 3D wiring is based on our imagination that, the wire is, wire went through only one course of the vessel. Sometimes wire may go even spirally, right? That's when everything is gone for toss. So your anti-clock may not be anti-clock, your clock may not be clock. So that's a whole problem. So I don't recommend it straight away. Best is parallel wire, right? And parallel wire, always your second wire should be higher tip load wire. And use first wire and your distal vessel on fluoro as a marker, and direct your second wire. Okay, so but most important here is when you are doing too much of parallel, so switching strategy early is very important. So if you want to switch to re-entry, switch early. If you do parallel wiring for 15 minutes, 20 minutes, and you end up in creating a huge subintimal hematoma, your re-entry with the Stingray also is. So try parallel wiring, right? Without much manipulation of subintimal space, right? It should be like you have to just direct wire. And if it is not happening, then switch to re-entry. Okay. So this switching from parallel wire to re-entry, I mean, this is very crucial. Okay, if you do more parallel wiring, your re-entry also fails. Otherwise, if you are good with re-entry, you can even directly switch to re-entry. See, Gladys Mongo is something equivalent to, Pilot 200 wire. Okay, the only difference in Gladys Mongo is it's a good wire for knuckle, but I've been using knuckles with pilot wire since almost more than 5 years. The one advantage over pilot with Gladys Mongo is in pilot, both Gladys and pilot gives you power knuckles because they are high tip load and stiff wires. Okay, so this power knuckle, so when you are pushing knuckle keeps shifting to the proximal part of the wire. Okay, the advantage in Gladius is knuckle won't shift because they made junction, that distal junction in such a way that knuckle won't shift. So that's the reason that is a good wire for knuckle. But otherwise, Gladius is something similar to Pilot 200. So where I use Pilot in CTO is when the course of CTO segment is not clear, then my escalation is to Pilot. Where the course is clear, I escalate to Gaia because I know the course, I know how to direct it. Okay, so to put it simply, ambiguous course, use Pilot wire, right? But don't try to direct it. You just keep rotating wire. Wire will take its track in the vessel. Rotation only keeps wire within the vessel architecture. When you start pushing wire, it can even go out of the vessel architecture. You understand? So it's not just the wire which is important. It is the technique which you are using with which that wire is being used by you is also important, right? You can send even Pilot 200, which has a tip load of 4.5. You can send it out. 4.5 is enough to send wire out of the vessel architecture if you just direct it and push it. Okay, but if you only rotate it, it won't go. Yeah. So that drilling and pushing, you have to use meticulously. Yeah. So when you are puncturing cap, you have to direct and push. That's all. In the CTO segment, you can rotate any 1 mm tip wire like Gaia. The 1 mm tip, see, when the tip is 1 mm, right, it tries to stay within the block. Okay. When overall tip is 3 mm, you can just imagine, right? At some point, it reaches the wall. Understand? That is the logic behind 1 mm tip. Why all these wires are pre-shaped with 1 mm? 1 mm tip tries to stay within the block. I think we'll move on to live and we can keep discussing during live. Okay.